Picked up this beauty broken on eBay, $975 shipped. We'll take it apart here, take a look at it, and see if we can't fix her. Some of my audio files have been corrupted and didn't record right, so I'll have to be re-recording them. Here you can see the oscilloscope with the LCD option. That's why there's all that extra room in the case. There's the LCD driver board. The CRT would take up substantially more room than the 10.8-inch LCD. So underneath that cover right there is the larger fan that directs airflow to the main board down underneath where all the magic happens. You can see the power supply there with the voltage rails and adjustments on the top. On the front panel there, floppies on the very top, hanging out the back. Around the side, you can see the expansion slot, or what may be a compact flash. I'm not really sure. It's pretty deep for a compact flash. It's probably some type of expansion. There you can see the printer cable coming out of the power supply. And then we're taking a look here at the VGA board. And it's also got the parallel port on it, and it has an internal VGA as well as an external, which is kind of peculiar. I wasn't expecting to see that. But if the LCD was bad, that's how I was planning on fixing it, was just replacing it with a VGA LCD and running the cable through the case. On the top there you got the IEEE and the RS-232. On the bottom, 3 of the 4 are populated. We got a 10 megahertz reference signal, I think a 500 megahertz, and I think an output trigger there. And then you get to see the larger fan in the mainline input out of the wall. Yeah, it's got the 4 channels in the front with an external and regular BNC calibration. It looks like you can store and recall waveforms on this particular model. Pretty useful function. The video of me doing the initial teardown didn't record correctly, as well as me going through and explaining it a little more what's going on. The oscilloscope was not turning on, and just getting a little fan noise out the back and stuff. Taking it apart, plugging it in. After tightening everything up, it started to come on. So I was taking a chance and reassembling it, thinking that it would be working after this. That maybe there's actually nothing wrong with it, and it just happened to be sold broken because it was being touchy and didn't want to come up. So I'm reassembling it now, and times 650% speed. Now that's working, let's turn around and have a look at it. You can hear multiple fans. It's kind of, I mean, you can hear it, you can notice it, but it's not too awfully loud. See if I can zoom in over. First we'll do the screen. So you got color coded on the 4 channels. I believe there's an option to split the graphs. Definitely not utilizing a lot of that screen area, but when you go for a menu or something, it does use that right side. Those buttons for
menu options, but it'd be nice if you got the full LCD as, a display. It's a 10.8-inch LCD, and definitely not getting that much graph space out of it. I mean, it has all the usual options, all stuff like that. Now over here on the buttons, you get the, you got the floppy on the top. You have your time base and your triggers are on the left, and your voltage per division and stuff there on the right, along with the auto setup button, and you have the persistence that you can turn on. Each channel is selectable by the buttons here on the top up here. You have to select in between each channel to change its voltage per division and time base. I'm not a huge fan of that, but it's a pretty good scope. A little lower there, and you have your math functions, which is LeCroy, in your display. This particular scope, let's see if we can status here. You got date, software version, software and hardware options. So I have my new LeCroy scope here behind me.
I picked it up on eBay for $975 with shipping off eBay, broken.
The screen wasn't working, but it now is. And I'm going to calibrate it and check some waveforms on it, and that should be a good buy for this piece of gear. Real quick here, here it is from the sitting on its back feet. There's the bottom of it. Got the postage scale out. We'll see how much this sucker weighs. I mean, it's pretty heavy. I definitely wouldn't call it portable. I got it to come in at 33 pounds, 15 ounces.
Wouldn't you know it, that didn't fix it. It's back to not turning on. The power supply fan looks like it's kicking on, but the larger fan isn't. So it looks like we'll have to take it apart again here and figure out the real culprit.
So let's open it back up, maybe measure some voltages on the rails. See what we get. I'm probing the positive on the red wire there, and if I can get it to spike at about 3.3 or 3.5 volts on that line for just a second when everything's turning on, just like that fan in the back here.
Including that fan back here. So something must be putting it in the shutdown mode, because the majority of the instrument isn't turning on. So let's see if we can get that fan in the shot back here.
It will spin up, and I'm getting voltage out. I've taken those 2 screws out of the VGA board, but our other 2 on the ends are being very stubborn, and they do not want to come out. Let's see if I can get it in there. I'm forcing it enough that I'm bending the screws, stripping it, if you will. It just does not want to come out. They are putting red Loctite. Let's see if you can. Red Loctite on the threads. That's the permanent strength thread Loctite. You would put blue on something that has the possibility of wiggling out vibrations that may need service later, but they are putting red Loctite on everything in here. So it does require a pretty substantial force to, it is rated to break free. I don't know what the specific foot-pounds of it are.
Those 2 there do not want to come out. So I think that I will have to resort to one of my favorite little tricks to get stubborn strip screws out of their current location. You can see that the head's just pretty much getting destroyed there. They just do not want to come out. So let's go over to the original method I was going to do. That's pretty much guaranteed to work.
You see there with the Dremel, cut it right across one of the, at the right angle, the other part of the Phillips head there. Now we can get a nice flat head in there, maybe get a little more leverage on it. After I hit it with the Dremel again, I got the sparks and stuff that I thought would show up the first time on the slow motion feature. You guys might not even see it if it wasn't that interesting. I had to go back in a little deeper on that one. I could feel that I didn't go deep enough, and I was gonna break the metal off on that screw. The heads are not very big. You know, especially with the dome, and then you're gonna have leverage off the base. You kind of want to get as deep down to the head as you can. I would say it's not gonna focus, but that is pretty much perfect depth. And this side I went a little too far in. If you can see the cut into it. I don't know if that will. See, I came through the other side, and this side is maybe a little too far too, but pretty much almost perfect. Because what you don't want to do is break the head off. If you mess this up, you're going to have to get a screw extractor pretty much. Because you can't cross it again the other way, because you're going to make the screw too weak. I would probably replace this screw if I think about it with a new screw from a hardware store or something. So there you have it. You got the fan out of the back. here's the AC power in. There's the fan connector and probably another fan connector. That fan only uses the 2 wires though. So, I mean, they have another one in there probably for a tack fan. Because maybe that one isn't. I was wondering where they were hiding the wires, and they weren't. They used plugs. Some pretty beefy contactors like that, directly out of the bottom. Same thing, just, you know, its mate.
I looked for a data sheet for this power supply for a while and didn't come up with diddly squat. So I decided to pull it out and see if I couldn't get it to turn on. And it looks like while it's not connected to the main board, that smaller pin socket there, that it is not going into shutdown mode. It looks like it's operating at least some extent. So I have it sitting here kind of rigged up, measuring voltages on the line.
There's 11 big pins on there. The most outer 2 pins are ground, and then the rest of them go as follows. Positive 15, negative 15, negative 5, positive 5, what should be negative 12, (3 volts), negative 2, (6 volts), and negative 6 volts.
Well, wouldn't you know it, after a little more poking around here, I got it to turn on. I found what is the culprit. That 12 volt line, that negative 12 volt line I was talking about there, actually isn't supposed to be a 12 volt line. That is supposed to be another ground. I went over to the main board on the oscilloscope and measured it, and it is ground connected. I thought it was negative 12 shorted out, but it actually looks like that the 12 volt, negative 12 volt line is not used at all in this system. At least not as actually connected to the oscilloscope. I was looking around seeing where that 12 volt line went, and I noticed this TO220 package here hanging off that heatsink loose as the prom queen, you know what I mean? And I kind of thought it was a voltage regulator or something, and that it wasn't getting any thermal relief and either went into shut off mode or burned itself up. And while I was tightening it up, it snapped off, and a little piece of metal fell out, and you can still see the contact in there, and it led me to believe that it was a mechanical temperature sensor that was shutting off and closing or opening based on temperature, like you know, the distance of the 2 metals. And sure enough, look at the data sheet, and that's what it's doing. I can see if you can see the 2 contacts that's still remaining in there. And so with the contacts open, it's not in shutdown mode, and with the contacts closed, it shuts down. So the way it must have broken, the other piece of metal that was in there was flopping back and forth and intermittently contacting and putting the oscilloscope in shutdown mode, rendering it useless. Now ordinarily you'd replace the part before you put it back together, but I don't have one offhand. I'm gonna have to order it. And since it has to close to put it in the shutdown mode based on the temperature, it'll work without it.
So let's give it a go. Look at that.
An 80 or 90 cent part failed and prevents the whole machine from working. That's what you don't want to have happen on a product.
So there it is, all up and running. Not on hope and prayer this time.
Actually properly repaired, so it'll be going to its final resting location. Not too bad a piece of gear for $975. It was a bit of a gamble, but we got it working. If you guys have any comments or questions, leave them below. Thanks for watching, and I'll catch you next time.